Use the quadratic formula to solve the equation x equals negative x squared minus 13x plus 42 equals 0. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So first I'm going to figure out what a, b, and c are. So I know a is 1 because that's in front of the x squared. B is negative 13 and c is 42. So now I get x equals negative b. So the opposite of negative 13 is positive 13, plus or minus the square root of 13 squared minus 4 times 1 times 42, all divided by 2 times 1. So that equals 13 plus or minus the square root. 13 squared is 169 minus 4 times 42. Well, 4 times 40 is 160, and 4 times 2 is 8, so this is 168, all divided by 2. So x equals 13 plus or minus the square root of 1, all divided by 2. X equals, the square root of 1 is just 1, so 13 plus or minus 1 divided by 2. Now I'm going to split it up. X equals 13 plus 1 over 2, which is 14 over 2, which is x equals 7, or x equals 13 minus 1 over 2, which equals 12 over 2, which means x equals 6. Does a quadratic equation always have two solutions? That is, does a parabola always intersect the x-axis twice? I'm going to go ahead and say no. If possible, draw an example of a parabola that only intersects the x-axis once. So an example would look like that, or it could be going down like that. What does it mean if a quadratic equation has no solution? Draw an example of a parabola that would cause this to happen. So it would be if it doesn't touch the x-axis, like that. They never cross the x-axis, so when the equation equals 0, they never have any solutions. Find the equation of the line through the point negative 2, 8 with a slope of 1/2. So if I graph it, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, well, the slope of 1/2 means I go up 1 and over 1, 2, or down 1 and over 1, 2. So the y-intercept is right here. That's at 9. So the equation is y equals 1/2 x plus 9. Okay, we could also figure that out by plugging into the equation y equals mx plus b. For y, I'm going to plug in 8. For m, I'd plug in 1/2. And for x, I'd plug in negative 2. And then I'd solve for b. So 8 equals 1/2 times negative 2 plus b. 8 equals 1/2 of negative 2 is just negative 1. So then add 1 and we get that b equals 9, which is what we got right here. Lynn asked some of her classmates how many people are normally home for dinner. She recorded her results in the histogram at right. How many classmates were surveyed? So let's see, in this bar we have 2. In this bar we've got 3. Here we've got 5, 5, and then 1. So 2 plus 3 is 5, plus 5 is 10, 15, 16 classmates. How many classmates have 8 or 9 people at home for dinner? So that's right here. So that would just be 1. Can you tell which is the most common number of people at home for dinner? No. But we know that it may be in between 4 and 8 because that's the most. Frequent data. Look at the two histograms below. They give you information about the heights of players on two basketball teams, the Tigers and the Panthers. Use the histograms to answer the questions. Which team has taller players? So let's see. The Tigers, it looks like they have a lot of players between 72 and 75 inches. They have one player that's short and one player that's tall. The Panthers have one player that's short. They're more evenly distributed. It looks like they have more along the higher end. So I would say the Panthers. Because if we look at these numbers, they have 1 there. This is 2, 5, 3, and 1. And the Panthers have 1, 3, 1, 2, 3, 2. Well, I guess we could say the Tigers, actually, if we think about it. The Tigers have 9 players taller than, let's see, 72 inches is 6 feet. The Tigers have 9 players taller than 6 feet. The Panthers only have taller than 6 feet. They have 5'7", only have 7 players taller than 6 feet. Which team has heights that vary more? So the Panthers' heights vary more because they are more spread out. Which team has more players that are about the same height? That would be the Tigers. The Tigers have 5 players between 72 and 75 inches.